Hey everyone, in this video we'll see like how do you create the embeddings from a document and how to store these embeddings into a vector database for rack system. So let's get started. So I'm in the second notebook or in the knowledge assistant module. So let's first see the document that we want to create this as a embedding. So I've created a Foodly company document.txt. So this is basically a Foodly document customer service and operation policy. So this is stored as a text and we want to use this as a we want to turn this as a embeddings, and we want to use this embeddings as a like document searcher in rack system, right? So this has some section like introduction, refund and compensation policy. Then also we have what are the information related to order cancellation, delivery operations, loyalty and rewards program. So this is basically a FAQ document that you have for your company, and this type of documents will not be accessible by any models like OpenAI or something, right? So this is your specific company internal documents and you don't want to share this with OpenAI or something, right? So this is where you turn all this data as a embeddings and store into a vector database, and then LLM models can search this embedding and can give you answers related to like all your related data, right? Suppose you want to know about what are the refund eligibility or what are the cancellation policy, right? So your model will able to understand that. So let's see like how do you turn these documents as the embeddings and store this in a vector database. Let me go back to the notebook. So first like this is just to read this document first. So basically I can read this as a document. I'm just printing in the as a text, and then what we're gonna do is like we're going to use a text loader from LangChain community. So we have already installed this particular library. So we first we are giving this a path and we are loading this documents, right? So this document will suppose this has a lot of different text files. So currently it has only one text file. So but if it has multiple text file, it can also read like this, right? So this document will have some metadata, right, and the page content. So if we see about the metadata, it will show you what is the source, right? And this is not it, right? You can also add your custom metadata like who has created this document, when it was created. So all those metadata can be used by OpenAI model or some other model to know more about this document, right? So this is why you'll be using the text loader from LangChain community. Once you do that, there's a step to chunk it, right? So basically you divide this big document into meaningful chunks. This is where we'll be using the recursive character text splitter from LangChain. So it uses a text splitter first. Basically you give three standard argument, that is chunk size. Basically the idea is you are chunk it in into 800 characters per chunk, right? And chunk overlap, that means between two chunk there could be 100 characters that overlap, right? So idea is, suppose you are having a sentence like I am going home, right? Do you want to come to park today, right? So basically suppose you are doing some chunking. Suppose you are right now if you're doing the chunking for the sentence, suppose you want to chunk like this, right? But you want to have some overlap between these two, right? So basically what we're doing is you are creating an overlap like this, like going home. So these are the character which are overlap between these two sentences, right? So that's the overall idea, that between those two chunks there are 100 characters which can overlap. That is done to preserve context, right? So these two chunks are related because this some chunk overlap. So that's the total idea. And then you give some separators. Separators means you give like slash n means try to split by paragraph first. If the paragraphs are too large, right, then you still, if it is too large, split by lines. If the even if it is bigger, then split by words. If not, split by characters, right? So recursively it will split the sentences and it will try to get a chunk size of 800. So it's a very handy tool to use this as a text splitter. So you see that we have created the chunks and it will have a different docs, right? So if you just scroll up, you see that it created 6 chunks, right? And this is the first chunk, right? and this is the second chunk, and similarly you will have different chunks like this, right? So you created the chunks first. So I've created, so if you do not have this catalog exists, you can create, or you can create this schema if it does not exist. But in previous video, we have created all this catalog and the schema. And now it's just a fancy function to just create this as a chunk ID, and the content is whatever the fetch content you have, and the metadata is whatever the metadata we created. And we can create this as a data frame, and at the end we can write this data frame as a table, right? So basically we are creating this delta table as fully polysic chunks. So this is how the table will look like. It has a chunk ID, it has a content, which is basically the whole content that you have, and which are chunked. So if you see, we have like 6 chunks there, and you also have a metadata. Once you do that, you have to create a table properties at delta enable change data feed, because think about that, suppose you are adding more policies here. So if you enable change data fit, it will incrementally load all these chunks, right? We'll see how do you create this as a vector database, right? So currently we have stored this as a delta table, and now you can create a vector database in Databricks and store this as a embeddings. So you can follow this document, but let me show you how you do that. First, let's go to compute, and you have a tab as vector database, vector search. This is the vector database that you'll create. So you can create an endpoint here. You can give any name like test, and you can either use standard or storage optimized. I've already created one DB that is calling that agent DB. Once you do that, let me go to that particular delta table first. So let me go to catalog, and this is the table that we created, right? So it has some sample data. Let me start the compute. Okay, this is the sample data that we have seen. Now it's very simple. You go to create, and you see there is a vector search index that is coming. You click there, and you first give a vector search index name, right? So I can name this as a Foodly index name test, and you define a primary key, right? Basically chunk ID can be a primary key, because if you remember, we have talked about that if you're incrementally loading those tables and you want database to take care of incremental loading, so you need to give a primary key. So chunk ID could be a primary key, because this is like incrementally we are giving, right? 1 2 3 4 5, right? Columns to sync. Currently we are syncing all the columns that exist here, and in embedding, this is where you want to select if you want to compute the embeddings, or if you use some existing embedding column. So you can also use some embedding model to create the embeddings on the table level itself, and then select the column name here. But we want to use Databricks embedding model to create the embedding for you. And the content, what's the column where you want to create? This is the content, right? Which is basically the document that you have. And then you can select the embedding model. So Databricks has some embedding model that is calling as large GTE model, or BGE large embedding model. So this is getting served in Databricks itself, so you can use this model. And vector search data point, this is where you will select the vector search DB, and then you're good to go. You can create the vector search index. So you see that index is created, you get index status as online, and you can also see the sample data. So you see there, it has the same column, chunk ID, content, and metadata, but you see there is a one more column that is created as a DB content vector. So this is basically the vectors that is created from your chunks. And you see that it has a lot of dimensions, right? So in our examples, we have seen that we took like just 3 dimension, but here basically you see that how many dimensions were created, right? So there are like 1023 dimensions, and in 1023 dimension your documents were categorized. So this is where you use a good embedding model to embed your documents properly, and then you get a proper meaning from that sentence, right? So you see that how easy it was to create a vector database, create an embedding model, use an embedding model, and use it to store the embeddings in a vector index, right? So to reiterate what we did, we first created a table, delta table, that has the chunks of it, right? Then we use that table to create a vector search index, and that vector search index is created like using a vector database. And now we can use this vector search index to connect it to your LLM model, and we'll get the information regarding whatever is stored in vector database. Now in the next video we'll see like how do you connect this vector database to your LLM model. So stay tuned.